Halley's Comet will not return to the inner solar system until 2061, but Earth still encounters material from its orbit twice every year. On the 11th of August, 2026, JPL Horizons placed the comet about 35 astronomical units from the Sun, beyond Neptune, moving inward at only 0.4 of a kilometer per second. So how can a comet that distant still write bright streaks across our sky? And why does it keep coming back? Its official designation is 1P Halley, but Edmond Halley did not discover it. People had recorded this comet for more than 2,000 years without knowing that the sightings belonged to the same returning object. In 1705, Halley used Newton's new ideas about gravity to compare bright comets seen in 1531, 1607, and 1682. Their paths looked strikingly similar. He proposed that they were one comet and predicted another return in 1758. The comet returned. For the first time, astronomers had correctly predicted the reappearance of a comet, and the object was later named in Halley's honor. We often call Halley's journey a 76-year orbit. That is an average, not a metronome. NASA lists measured intervals ranging from a little over 74 years to more than 79. The gravity of planets slightly reshapes the timing from one return to the next. The orbit is also unusual. Halley travels around the Sun in the direction opposite the planets, along a path tilted about 18 degrees to Earth's orbital plane. Near the far end of that long ellipse, it travels slowly. On our date-stamped JPL reading, its speed around the Sun is just under 1 kilometer per second. Near the Sun, gravity turns the same comet into a sprinter. During its 1986 passage, it swung inside the orbit of Venus and moved more than 50 times faster. This huge change of scale is the reason Halley can spend decades as a faint, frozen body in the dark, then return to the inner solar system in a blaze of activity. The solid nucleus is much smaller than the famous comet in our imagination, roughly 15 kilometers long and about 8 kilometers wide. It is also extremely dark, reflecting only about 3% of the light that reaches it. As Halley approaches the Sun, heat changes ice into gas. Gas and dust expand into a coma around the nucleus. Pressure from sunlight and the stream of charged particles from the Sun then push material outward. That produces two main tails, a broader curved dust tail and a straighter ion tail. The important direction is away from the Sun. A comet's tails do not simply trail behind it like hair in the wind. As the comet rounds the Sun, the tails can swing so that they point partly ahead of its direction of travel. In 1986, an international fleet of spacecraft met Halley. ESA's Giotto probe made the closest pass. On the night of the 13th to 14th of March, it flew within 596 kilometers of the nucleus. Its camera revealed an irregular dark body hidden inside the brilliant coma, with jets of material escaping from active regions. For the first time, the world's most famous comet was not just a glowing shape in a telescope. It was a place. Every time Halley warms in the inner solar system, it sheds ice and rocky dust. Over many orbits, those grains spread around parts of the comet's path. Earth crosses that distributed material in 2 different seasons. The Eta Aquariids arrive around early May. The Orionids arrive around mid-October. Both are linked to 1P Halley, even though the comet itself is now billions of kilometers away. Those brief streaks are not tiny comets racing past Earth. They are grains meeting our atmosphere at about 66 kilometers per second, heating the surrounding air and disappearing high above us. The comet does not have to be nearby. Its orbit has left a trail that Earth can revisit. So where is Halley's Comet now? On the 11th of August, 2026, it is far beyond Neptune and slowly moving sunward. It will not return to the inner solar system until 2061. But its story is already overhead. in an orbit predicted centuries ago, in a nucleus photographed by Giotto, and in 2 meteor showers that return every year. Halley is not gone. It is simply between visits. In the next episode, we will follow one grain from a comet's trail to the flash we call a meteor.